research and also the industrial world, and how the ideas can be turned into a real world application. And then we are honored and excited to welcome three of the most I would say professional that shaping the quantum technologies in Spain and beyond. So welcome Carlos, Irene, and Ruben. So, and then the session will be structured as in two parts. The first one would give 20 minutes to each to present his resume and career and what he's doing in life. And then the second part will be a bunch of questions to everyone, general questions and also specific to each one. So welcome, and let's start the session.
Yeah, thank you everyone for coming here. Now we're gonna first introduce Carlos Garcia Meca. He holds a PhD in photonics and he's currently the head of the photonic and quantum technologies at Navantia. So to tell him story, who best than he himself? So please, could you introduce yourself? Thank you everyone, please.
Hi everyone, good afternoon. Okay, so first of all, thank you very much for the organizers, for inviting me to be here today. It's a pleasure and an honor. I was a student of this master last year, an old one, much older than you guys. So yeah, it's a pleasure to be here again this year. I have to apologize because I haven't brought a PowerPoint presentation with me because it was a misunderstanding and I was told that we didn't going to do it this way. So I will try to tell you just using my voice about my professional story. I must warn you that probably all of you know much more quantum physics than me, because I am a complete newbie in this field. I started last year, but a very enthusiastic one. And but yeah, maybe telling you my professional story might be helpful for you at some point. So let's start. Okay, so like many years ago, I started to study telecommunication engineering at the Polytechnic University of Valencia. I decided to study this degree. It was then by that time it was a 5-year degree, and my favorite subjects were at high school were mathematics and physics, probably like you, and so but at that time the professional perspectives of these fields were not as good as today. Fortunately today they are much better, and telecommunication engineering was on the rise with many offers of well-paid jobs and everything. So you try to strike a balance and say, okay, mathematics, a little bit of mathematics, a little bit of physics, and also engineering. Okay, let's go for it. So I finished my degree, and I started to work at an electronics company that was developing electronics for cars, for the automotive industry. And it was like a little bit of, I don't know, I had a void, something. I felt that I was not fulfilling my initial interests, to work with physics and mathematics and everything. And by chance, I found an offer to carry out a PhD in nanophotonics in the Nanophotonics Technology Center of my university, the Polytechnic University of Valencia. So I asked for information and apply for the offer, for the position, and I fortunately was selected. So So I changed absolutely, totally my professional career and started to do a PhD in photonics. And I must say that it was probably the best decision I have ever made. Although to start with, the salary was like half the one I had in the electronics company, but actually I wasn't worried about that at that time because I was really enjoying what I was doing. I was amazed by the concepts I was learning. My PhD was about like some new fields in advanced electromagnetism. Maybe you know some of them: metamaterials, plasmonics, extraordinary transmission, transformation optics, invisibility, and things like I couldn't believe when I first read them in papers. So yeah, I was very happy. And I also, during the PhD, I also did a master's degree in telecommunication, which was mandatory by that time. And I finished 4 years later, I finished the PhD. And I started to work as a postdoc in the Nanophotonics Technology Center there. I won a few grants. First, it was a few postdoc grants. First, it was called Val I+D postdoc grant from the regional Valencian government. And it allowed me to carry out an internship in the Astrophysics Institute of Andalusia to explore the applications of general relativity in electromagnetic engineering, something that was also quite new by that time. And I had the chance to work with an amazing scientist there, Carlos Barceló, an expert in general relativity, and it was also, I had a very nice time there. Then it was Juan de la Cierva, and also a project for national project for young researchers in a highly competitive call. So it seems that well, years passed, and I was quite satisfied with my evolution. I thought everything was going very well, and I wanted to enter the academic, you know, to gain a tenured position in the university. And by that time, in my university, the only way to achieve that was through a Ramon y Cajal grant. Okay, so then I think I have chances, everything's going good. So I applied for it, and the evaluation was not very good, and so I expected much better evaluation. I got a little bit frustrated. Yeah, I didn't know exactly what to do. Try again, and then I received an offer to create and lead a research area in a spin-off company of my research institute, which is called Das Photonics. It was it is a company that works developing photonic technology for the defense and aerospace sectors. And the idea was to create a research area within the company, because the company was already doing research in collaboration with the university, but they wanted to have their own research area, just to have full control of the research activities they were performing and not depending on the university, and that was the idea. So it was quite appealing for me. I accepted, and yeah, I started to build this area to, let's say, develop a research strategy, to build a team, prepare project proposals, to get funding, also develop projects. And yeah, it was a very exciting experience, because I didn't have knowledge on team management or project managing, and so I had the opportunity to learn these skills, which, by the way, I think that they are quite important, especially, well, also in academia, but also if you want to work in industry, this is a very valued ability. And everything was going very well. I ended up with a team of 11 people, all doing research. We gained quite a lot of projects in different fields: metasurfaces, artificial intelligence, integrated photonics, free space photonics, and also some of them related with quantum technologies in the last years. So I started in 2020, and by 2023 or something like this, the financial situation of the company started to become unstable and complicated. A new investor entered the company, a big investor, and this quite changed the philosophy, the initial, like, extremely research-oriented and deep tech-oriented philosophy of the company to something more product-oriented and results-oriented and profit-oriented and everything. Of course, you want to get profit in a company, but the spirit was quite different. Yeah, the atmosphere became more negative. Everything was different, and a workmate and I that have been friends for many years started to get burnt out, and so we wanted to. We thought that we needed a change, but we were like, sometimes you are change resistant and you don't put the effort to change and to look for other opportunities, but I recommend that you do that if you feel that you are not in the right place. Fortunately, I received by that time an unexpected and very timely offer. Well, it was in 2024. Well, I have to say first that before that, all that happened, I enrolled in the master in quantum technologies for mainly for two reasons. One of them was that we, as I mentioned before, we have started to have to be involved in projects related to quantum technologies, and the other reason was because of my own curiosity, because well, I didn't have a background in quantum at all, but you hear all these amazing concepts related to quantum physics, entanglement, superposition, the weird way in which quantum measurements work, and also the amazing and disruptive applications that are expected from quantum technologies like quantum computing and cryptography and everything. So I was very, very curious about this field, and that made me enroll in the master. And then comes what I was saying. I received an offer from Navantia, and it was also very similar. The role they proposed was quite similar to the one that I had in my first company, because they were starting to be very interested in photonics, exploring the potential applications of photonics for the naval industry. This happens to me a lot, that when I say that I work at Navantia, people say, but what do you do? Navantia is doing ships and submarines, and where is the photonics and the quantum? But of course, a ship has a lot of very complex instruments and communications instruments, sensing, of course, computers and many things. And there are a lot of like subsystems of a ship or of a submarine, or even of underwater drone, that we are also working on that nowadays. that require or that would benefit from photonics and from quantum technologies. So the idea was to build a photonics department from scratch again. And I thought that it was the change I needed, so I took the step, made my decision, and moved to Navantia. It was in October last year. The department was initially going to be only about photonics, but they told me, I have seen that you also have a master's degree in quantum, right? Yeah, we don't know much quantum physics here at Navantia. So why don't we call it the Photonics and Quantum Department instead of only photonics? So, okay, that's good. It was very exciting by that time, but also I was a little bit scared because I am a newcomer. I know only some basics. As I mentioned before, I'm very enthusiastic, but yeah, there's a lot of things to learn yet. But yeah, the idea was also to collaborate with universities, and also having been a student of this master allowed me to get to know many top quantum scientists from Spain, which were my teachers in different subjects. And now this is allowing me to establish or facilitating the establishment of collaborations and everything. So basically, this is my story. Now we are 4 people, and we plan to incorporate more employees in my department, working in quantum and in photonics. 2 of them are going to come in September, and we are growing. We have a new office it has been set in Valencia, because there's an important photonics pole in Valencia with many research institutes and photonics companies. And yeah, we plan even to have a small laboratory in the future. So we are now preparing proposals to get funding, setting alliances with universities, and basically that's all. So that's all I wanted to tell you today.
So we're gonna save the questions for later, okay? Yeah, thank you for your story. It was very inspiring, especially how, thanks to the master, you were able to change the name of the department at Navantia. We really like that. And now, without further ado, we would like to introduce Dr. Irene Alda. She's currently the director of the Applied Maths degree at IE University, and she holds a PhD on levitating nanoparticles. So without further ado, please join me in welcoming Irene Alda.
Hi, good afternoon. Just out of curiosity, have you heard IE University before? Yeah? Did you know that they have something related to science and technology? Okay, that's okay. That was me 3 years ago as well. So we've been sponsors of this workshop, so I'm very, very happy to be here. I think we sponsored your adrenaline yesterday at the Parque de Atracciones, so I really hope you had a nice time. So I'm going to be talking about quantum and education more from like an undergrad level. But before getting started, I want to give you a little bit of context. Just like Carlos, I also come from a photonics background. So let me go back 10 years time, 2015, where I did my PhD at ICFO in Barcelona. So I was part of the optomechanics team, which was, I think the group back then was called Plasma Nano-Optics or something like that, led by Professor, I'll say his name wrong because it's French, Romain Guidon. Yeah. And we were basically doing levitation of nanoparticles. So I will be a little bit of the Grinch, I think, in this workshop, in the sense that as an experimental physicist, it's really tough, yeah? Like how complex all of these systems are, from cryogenics, I was fortunate not to have to work with cryogenics, but with vacuum, like how delicate all of these systems are. So I did from like clean room to, well, yeah, basically levitating particles. Okay, so I also wanted to introduce a little bit about IE because, I mean, I didn't know about IE either a few years back. Probably most of you, if you have heard of it, it's mostly known as a business school. Okay, that's where it started. And it became a university in 2006. And in 2015, it started to have more degrees related to science. One of the first one was data and business analytics. And as you can see, very, very recently, actually the School of Science and Technology was started. And I'm there basically taking care of applied mathematics. So there are very many different schools, and these are the different programs we have. So as I said, data and business analytics, we have a computer science degree in AI, environmental science for sustainability, and applied mathematics. I would say IE is very much on the like innovation, technology. So one of the things that I'm going to show you is very much related to quantum technologies. So where, and I'll shoot a question to you, where do you think quantum starts in your academic degree? Like, where does it appear for the first time? If you're, I guess, a physicist, I don't know if in engineering they talk to you a little bit about quantum. Yeah? Third year, okay? Does anyone want to say before? Second year? Okay, what if I told, yeah? Okay, that's okay. That's really sad. No, you have that type of answer from normal. So to give you a bit of context, I teach linear algebra to first years, and I show them the Schrödinger equation. It's true, I don't explain them to them. I tell them just to, like, if they're interested, they will see that later on in their life. But when you learn about diagonalization in linear algebra as a physicist, they never tell you that the Schrödinger equation is a diagonalization problem, where your wave function is the vector, and you have an operator, and then the energy is that eigenvalue. And I think that as physicists, that's kind of sad they don't like sell it to us, because when you study linear algebra, I find that it's like, as a person who teaches it, I find that it's like a really tough subject to chew on. Yeah, so I think that from very early on, we can start giving those little sprinkles of where those foundational math basically is going to build up. So I hope you get my meme. So as I said, we try to introduce those ideas of quantum in our, that's Dua Lipa. Yeah, she has a book club, and that's why it's supposed to be funny. Huge fan, don't make me sing here though, please. Obviously in our physics courses, we also talk about quantum physics. And then something that we started from very early on in the applied math program was to offer an introduction to quantum computing. Because basically, once you're comfortable with vector spaces and all the machinery of linear algebra, you're basically ready to mathematically understand quantum computing. And I think this is very, very important from a very early stage to basically, again, sprinkle kind of complicated concepts, but that are, let's say, available very early on. So a little bit related to this and to, I think we all like to gamify things if possible, because it makes it more entertaining, easier to learn. And I think that in education, that's very, very important. Obviously, without losing as much as possible the rigor and formalism that is non-negotiable. Oh wait, I was jumping onto my next slide, sorry. This is another examples of things we've done. This April, we took students to the BSC, to the Barcelona Supercomputing Center. They have 2 quantum computers there. I think when we went, one was not working. That one's there just for display. Obviously, that's not it. And the other one, I think, had around 10 or 15 qubits. So that was like really just like fun to see. If you ever go, I highly recommend, if you go to Barcelona or a few of you want to visit, if you write as a group, they'll probably offer you a visit. So highly recommended to do that if you're interested. Okay, so thanks to our executive vice dean, Rafi Sour, so basically my boss, she basically put a lot of emphasis in being able to make tangible quantum computing. Yeah, so one of the things that we've developed at our school is a quantum VR experience. So basically with the VR glasses, it's an interactive game, and you basically learn, ideally, besides playing, some quantum computing concepts. I'm gonna show you a video in a little bit, but and I'll say this again, but during the poster session, there's gonna be 2 colleagues from the university here, like with a little spot in the VR glasses, so you can try it out. Yeah, so if you're up for it, please go. So these are the people who have been behind. So the instructional designers, these will be the 2 faces that will be there with the VR glasses later during the poster session, okay? Oh, hi. And then, how many Spanish people do I have in the room? Okay, a few. Can you guess who that is? I mean, you saw the name, so maybe I should have like erased that. Yeah, so Eduardo Sáenz de Cabezón has participated in the storyline of this activity. Basically, he was the one that gave us the introduction to quantum computing. So we started also collaborating together in this project. So I hope you enjoy it if you decide to give it a try. I want to show you a video. It's a 1-minute trailer, like very flashy with nice noises. So I hope that this works.
Quantum computing is expected to be one of the most disruptive technologies of the century and even of the history of mankind. IE Quantum Hack is a multiplayer collaborative learning experience where players immerse in quantum computing and explore key concepts such as qubits, entanglement, and quantum coherence. In this gaming experience, players visit IE's quantum computing facility on the day a quantum hacker sabotages the facilities with sinister goals. To win the game, players must grasp the fundamentals of quantum computing while also leveraging communication, curiosity, and problem solving to overcome a series of challenges together. Can you help IE keep one of the world's most powerful technologies in the right hands?
Did you find that cool? Did the team do a good job? Okay, I'll tell them that. Nice. Like, I have it.
Hemos venido al Congreso para entregar las más de 200.000 firmas que hemos recogido pidiendo un alto el fuego absoluto e inmediato. Si no se toman medidas urgentes, ya estamos condenando a muerte a casi 1 millón de niños. Desde Save the Children no vamos a dejar ni un momento de exigir que la población de Gaza reciba.
Fair enough. Okay, great to have you laughing. What was I gonna say? So I'll tell the team that. They'll be very happy to hear that. It's the first time I show the trailer, but obviously with YouTube, I guess things started happening playing after. Thankfully, it wasn't like a weird ad or anything. So where are we using these types of experience currently? So we're introducing it this year in our physics courses, so students can basically make quantum computing tangible in some way. We're also introducing it this year in the Introduction to Quantum Computing course. We always, every year, organize a Women in STEM event. That's where we basically kicked off the experience, and I hope it becomes like a signature of it. This year it's been included in summer school activities and in events with alumni and everything okay? No? Okay. So as you see, like a very wide variety of people. And is that what was playing behind me? And the common thing to all of this is that it's mostly people that have not really been in touch with anything quantum previously. So I would say it's quite of a challenge, and here I think it's always that balance, right? Like, I want to introduce a very complex concept in a way that, let's say, someone in their last year of high school can understand. And like, I'm gonna need to lose a little bit of rigor in order to basically bring that complex system so it's understandable at a, let's say, reasonable level. So just wanted to show you like what that looks like. So whenever we do this activity, we do like a 15-minute presentation about some quantum concepts. So like entanglement, the double slit, what is quantum computing versus a normal computer. So these are some of examples of my slides. So like the Schrodinger plates, like it's not exactly like that, but it gives people an image or something or a metaphor to understand these very weird, complex in nature at such a nanoscale word, of course. And I think that's all for my part. I think the questions were for later, but I did want to show this slide. So please know that we are always looking for talent. Yeah, so if you want to take a picture or scan that QR, that would be amazing. As the person who is responsible for the math program, I'm always looking for adjunct professors to teach courses. You're smiling. But also our school, since we're basically growing very much in number of students, we're always looking also for supervisor for undergraduate thesis projects. Our university has an agreement with the SEEK already, like an umbrella. So if any of you at any point of you start a PhD or think that's something you would enjoy, I'll be more than happy to talk with you. So yeah, thank you. I think that's all.
Okay, thank you so much, Irene. Yeah, I love how the trailer was a good showcase of quantum superposition of videos. So yeah, that was really cool. And lastly, but definitely not least, we would like to introduce Dr. Rubén Criado. He is currently the CEO at Archimea Research Center, and furthermore, he's also the general manager at Archimea Research Center. So without further ado, Rubén Criado. Thank you so much.
Well, hi to everyone. First of all, thanks a lot for inviting me, and sorry for being late again. So I didn't prepare a presentation, and I think it's convenient because I see you. Most of you, I understand that are PhD students or postdoc, and I would like to share a little bit about my story. I started my degree on telecommunication engineering. The people in Spain know what it is. Outside of Spain, let's say, is something similar to electrical engineering, kind of, but with a lot of programming on top of that. I have to say that when I started my degree, I didn't have a vocation. Okay, some people have a vocation to be a researcher, to be an entrepreneur. I didn't have any vocation. I just enrolled to this degree because, you know, people with high grades were supposed to enroll that degree. I like physics, I like maths, that's true, but I didn't have a vocation. So a lot of years after that, I have to tell you that I don't have a vocation. Okay. So in my degree, I really did not enjoy the first years to the point that in second year I started to think that I need to finish this thing as quick as possible and get a job and watch some other things. But you know, things in life. In my third course, I have the opportunity to be an intern in a laboratory in the university, and that's how I started to work in research. Okay, I started working in photonics in that lab. I had the opportunity very soon to get in touch with really cool experiments, interferometers for fusion plasma. I had the opportunity to install in Ciemat a 30-meter long 3-color interferometer. Very cool. And with that, I finished my degree, and I say, okay, I like this thing, this research thing. I like photonics and, let's say, the laboratory experimental thing. So I think I'm going to enroll to a PhD. So I started to look abroad. I almost got a PhD in Japan, almost got a PhD in Singapore, and finally I start my PhD in the very same place I made my degree. But it was cool. It was a very nice project, and I have to say that it was, you know, looking from the future, I have to say it was a good decision, because I made a quick PhD for that time. This was a lot of years ago. In my department, people used to get the PhD in 6-8 years, some of them in 10 years, something like that. I managed to get my PhD in 3 years and 5 months. And I finished my PhD with the dissertation, a company, a wife, and my first child. Everything, you know, was a consequence of this PhD. I met my wife in the lab. We married during my PhD, and we had our first year. So it was, let's say, a very fructiferous PhD. But let's get back to the entrepreneurship part, okay? In my PhD, we have some very nice results. Let me tell you that the first 2 years, I was really frustrated because I wasn't able to publish anything, and I was really frustrated. I won't be able to finish a dissertation in all my life, and this is not working at the lab, but somehow, you know, at some point, everything started to work, and we managed to publish a lot of things and all that. Some of the results were very interesting, and I have, at that time, some interest in company, in business, in this kind of thing. Okay, at that time, the term entrepreneurship and startup and spin-off, it was just starting. You know, to make a company, it was really, not really weird, but definitely more. Well, it was unusual at that time. But well, this thing went into my mind in the last year of my PhD. You know, the thing that, well, at some time I would like to start a company or try to be an entrepreneur. I don't know, something. You know, it was like an inception in my mind. And also at that time in Spain, we were suffering economic crisis. We didn't have an industry able to hire PhDs. So most of the PhDs, the only or almost only career path was the university, let's say the tenure track. And well, we were always, you know, complaining about, well, we don't have an industry with high tech. Most of the researchers in Spain have to leave the country and go abroad. And one day, I attended to a conference in which I saw a guy 1 year older than me. I met him in the campus, and he was presenting his company. And that was, you know, an inflection point for me, because I see the example in him, on him, and I say, okay, this can be done. I mean, this thing of creating a company is not like something, wow, somehow someone will create a company. It's something that you can try. So we decided to try, and at that time we did everything horrible. I mean, Irene and the business part of the yeah would be well, it was horrendous, okay, because we made the typical mistake that at that time most of the spin-off companies were made, and was starting a company from a technology. So basically, you start a company with a solution for a problem that you don't know, or you don't know if the problem even exists. Okay, so it was not the ideal case, but we started the company. This company was Lud Wave Labs. This company were running for 7 years or something like that. We managed to raise. I'm talking about 12, 13 years ago. We managed to raise, just to start with a PowerPoint, almost 1 million in the first year. That was a very good result at that time, especially with a deep tech company. The term deep tech wasn't in the table, okay? Basically, deep tech was weird things and things with no return inside. But we started the company, and well, I have to say that I learned a lot in a lot of areas. Please don't never think that if you don't have a skill, you cannot learn it. Let me tell you an example, and this is something that is embarrassing for me. So I will share this with you, but it's something really embarrassing for me. When I was finishing my degree, I mean, like a man with 21 years old, I was so shy that I wasn't able to say hi to the girls in my class. That's the kind of shy that I was. I was an engineer, so everything that was not, you know, under control was frustrating for me. It meant anxiety. So the thing of talk with people to communicate, it was something that's not for me, okay? And somehow with the company, I was, let's say, pushed to learn all of these things, okay? And well, I learned to communicate, I learned social skills, I learned a lot of things, okay? So that was a really, really important learn. And well, after some years, okay, we have to pivot the company, the product line, and all that. An industrial company invest on us. It was Archimia, okay? So Archimia invested on us, and I started to work, let's say, under the umbrella of Archimia 7 years ago. So I start to be curious and you know, to well, talk a lot with people and well, try to learn about the R&D in the company. I was basically a pain in the ass, because basically I was asking to everyone to tell me things. I tried to put some R&D projects the first years in place without even be a company, a person of Archimia. I was just a side company, or let's say a invested company of Archimia. But well, at that time Archimia was have a revenue of about 9 million. All the Archimia group have a revenue of 9 million. 80 people, but was starting to grow very, very fast. And my president, he's also a PhD. He say, okay, we need a corporate research center. And they offer me the job, okay, to start from scratch a corporate innovation research center for disruptive technologies. And well, in just 2 months before COVID, they sent me to Tenerife, to Canary Island. We decided to start the research center over there. And I started all the center from scratch. Well, this was really cool, okay, because at that time, my company was like it was in a standby, you know, situation. We sell some products, but we were not growing. So basically, we were maintaining a company of 5, 7 people. So I decided to just well let the company and went to another stage on my life. So it was really cool, okay, because basically they gave me a lot of autonomy to design the center, to design everything, the culture, everything. It was really cool. So what do we do in Archimia Research Center? Okay. When we started, we have 2 objectives in mind. The first one is that we needed to create differential science and technologies. You know, like a university, but we needed to focus on scientific excellence. And the second one that is the difference is that we needed to accelerate a lot of these technologies to the market, a lot. So I put in place a market intelligence team in the center. We put in place some processes to select the projects, to analyze the uncertainty of the projects, the potential, the impact, well, this kind of processes. Let's say that we were working and we work in a lot of things like a startup, but in science and research. And well, in 5 years, we managed to grow until 100 researchers. In all Archimia group right now, we are 600 people. We have a revenue of 120 million. That's the growth in these 7 years, from 9 million to 120. And this can give you an idea of what is the bet in Archimia on technology. I mean, we have a space, we have defense, and we have new technologies. And only in new technologies we are about 160 people, and 100 are in disruptive technologies, okay? So we are not 100 people making research. We are 100 people making very disruptive research. The R&D, the product R&D is done in the business units. So that can give you an idea of the amount of investment in Archimia on technology in the different stages of maturity. So 5 years later, in Archimia Research Center, we managed to create several spin-offs. Okay, one spin-off is selling in US a lot with clients like Amazon Prime, Netflix, and all that. We have another company of robotics that is selling to MIT, to Toyota, doing really cool things. We have a company in biotech area in which we are starting now the clinical trial, the phase 1 of clinical trials for a molecule for ALS, okay? And this is the first molecule in the world that has demonstrated to stop ALS. So this is a very amazing project. The other robotics spin-out is called Pulsar. We made actuators for humanoids, for drones, for even for electric motors for boats. And we have a technology that is unique in the world, basically solving a lot of bottlenecks that actually are in the field. On top of that, we managed to get the QCircle project. QCircle is the biggest project in the European Union for this kind of excellence centers. Okay, it's 30 million to become a European excellence center. In our case, the background is quantum, but we apply quantum to a lot of things. We made a very applied research. And on top of that, we cover most of our budget. Our Alchemia group only covers 15% of our budget, with more than 100 researchers and making a lot of expenses in R&D. We organize ourselves in orbitals. I don't like the department organization because I used to work in the university, and in the university, you know what happens with a department or a group? You divide the groups eventually by 2 until you have very small groups. The collaboration is not as strange, but well, we have to organize ourselves in some way, so we call the groups orbitals. We have a quantum photonics orbital, artificial intelligence, robotics, and biotechnology. And well, we are growing a lot. We are opening a research center in US, in Pasadena. So if some of you is interested in, start almost from scratch, a nice research center with all our support, of course, in Pasadena, in a very nice place in Los Angeles, let me know, because we are hiring for that. A postdoc with, a generalistic profile. And well, I think that's all. So thanks a lot, and I hope you enjoy the workshop.
Yeah, thank you so much for coming. Now we're gonna take a little break, 5 minutes, and we'll be back. By the way, I totally understand why it took you guys so long to perform the PhD in your department. Children and wife, probably took me like 10 years to do it. But yeah, in 5 minutes we'll be back, okay? So thank you. Gracias por mentir bien, pero no. Vale, bueno. ¿Dónde lo dejamos?
¿El qué? Ah, sí, por ahí.
Vale. Porque, claro, es que esto no sé cómo...